Hello everybody and welcome to a maths video. Today I'll be doing about polygons. So I've made this PowerPoint. I'm going to explain how to find the interior and exterior angles of a polygon and explain what it is as well. So let's get started. And before we start, don't forget to like and subscribe and turn on the notifications as well. So a polygon is a flat shape which in maths is called a two-dimensional closed shape, so that means it's flat. It's not three-dimensional, which is also for short 2D or 3D. So it's got straight lines and no curves, like these two here. So that's a hexagon and that's a pentagon. 5 sides, 6 sides. So as I've already said that, and the shape doesn't have to be regular. So it could be irregular, which means that some sides are different to others, or angles, or stuff like that. So it doesn't have to have the same length of sides and the same degrees of angles. So hopefully you'll get an idea of what a polygon is. So here you've got sum of all interior angles. So the interior angles, so if I go back to this slide, are those just there. So these angles, so where the vertex is, the corner is called a vertex. Vertices for long. It's spelt like this. Vertices. So those are the angles. So the sum of it, for example, here I'll read this out so it's easiest to when we're coming to do the actual calculation. So a triangle has 3 sides and the sum of all the interior angles equals 180 degrees. A square has 4 sides and you can fit 2 triangles in a square. This means, for example, if you draw a square, let me find one just here. So this is the best square I could find. I mean, I know it has a bit of a folded edge, but anyway, so for example, if you put one vertex to one vertex, you can fit 2 triangles in there. A triangle is a triangle, so there's only one you can fit from there. For example, if we go to a pentagon, because that's my next one, you can fit 3 triangles in here, because we go from that one to there and to there. Or you can do it any way, really. You can go except from the one next door, so it has to be to either there or there. It can't be next to each other, so it has to be opposite at one point, and that can go to there. It depends. Same for hexagon, you can go it either way, from there to there, or from there to there, there to there. You can fit in 4 triangles in a hexagon, so you should notice a pattern there, because the amount of vertices or sides in a shape is 2 more than the amount of triangles in the shape. So if there's 1,000 vertices, there should be 998 triangles. So, and also I just want to say the sum of the interior angles of a square is 360 degrees, but a pentagon has 540 degrees. A hexagon would have 720 degrees. So there you can see we're adding 180 degrees each time we add on a side or vertex. So in order to find the degrees of all the interior angles in terms of n, which means we're using n to put a number in there. So n could be any number. It could be 1,000,000, it could be 1. Well, actually not 1, because 1 is not a shape. It has to be 3 or more. So let's put 3 in there, for example. So 3 minus 1 minus 2. 3 minus 2 is 1 times 180 is 180. So we already know that. But here I've done 1. So 10 sides, for example, which is a decagon. So n this time equals 10. A formula for n always equals the number of sides, then minus 2 as the amount of triangles. So 10 minus 2 equals 8, and then 8 times 180 equals 1440. So it works. This formula is a good formula to remember for maths. So now if we go on to the sum of the exterior angles, so let me get a shape to put in here. I'll get a hexagon as well. So here we do have a pentagon and a hexagon. Now this hexagon, I've made it a bit longer there, as you can see, because this is a irregular hexagon, because these two are different from these four sides. But you can always alter the size difference like that. You can make it tiny if you want, but just keep it like that for now. So the sum of all the interior angle plus an exterior angle would always equal 180 degrees. So we measure the exterior angles. For example, we go from that point and we go down. So pretend if we draw an imaginary line there, we always measure this part here. So if we draw a line down there, we measure that part there. Or if we're going the other way, for example, if we're coming up from here, we draw an imaginary line there, we're measuring that part. So this angle on one side plus that would always equal 180. But the sum of all the exterior angles, like that, not the whole bit, because this whole bit here, so if we have the interior angle plus the whole, so both sides of the exterior angle, that would equal 360. But if we add the whole of the exterior angles together, as I've just showed you with the line, and then you put an angle there, would equal 360 degrees for any shape. If you want to work out the number of diagonals without knowing, so this is a bit different to the sum of all exterior angles, it's just something which is quite necessary of a polygon. So n brackets n minus 3 brackets divided by 2 is a formula for, so n equals, let's say 8 for example. So if we put 8 there, so the 8, this means times. So if you see brackets, you always do the brackets first if you follow bit maths, which means brackets, indices, which is like powers, the power of 2, power of 3, power of 4, and then division, multiplication, addition and subtraction. So if we put the number 8 there, and the number 8 there, because we know that n equals 8, this would be like this. So I've just used this forward slash sign for the divide, but you could just draw a line under here if you're doing it on paper, because that would also mean division, and then put a 2. So 8 minus 3 equals 5 times, so the number outside, if you don't see a times sign you get confused, this means that all it means is just times if you don't see a times sign like that. So 8 minus 3 equals 5, times 8 equals 40, and then you divide by 2 to get 20. So it works the same for anything. If you put 20,000 there, and you minus 3 divided by 2, so 20,000 minus 3 times 8 divided by 2 will still get you the right answer. So that formula again is really good for finding diagonals of the shapes. So for an irregular, let's go back to the sum of all exterior angles of a polygon. So an irregular polygon still equals 360 degrees, the exterior angles, but there's different measurements for each exterior angle. So going back to interior angles, but let me go here because I have a pentagon and a hexagon here. So if we have something like a missing angle there and we have the other measurements, we know that the whole of the interior angles of a pentagon equals 540. We just need to add the ones up and minus, do 540 minus all these added up. So hopefully now you know how to find interior angles, and hopefully you know how to find exterior angles as well. Even if we have something like all the exterior angles but one, we could always add all the rest up and do 360 minus all of them added up on the exterior, because we know that all the exterior angles equals up to 360 degrees regardless of what shape. So this concludes this video. So if you need anything, just put it in the comment section, and make sure you like and subscribe to get more videos, and of course I'll see you next time.